So if you remember from our very first lectures is in a CAD class or in any computer-aided design course, one of the ultimate goals is for you to basically have a design idea, come up with the 3D representation of that object that we did in part design. If there are several of them, make an assembly design. But ultimately, when you want to manufacture this, you have to create these multi-view orthographic projections, right? So basically project the object onto 6 planes of this glass box that completely contains the object in a perpendicular way. So that's why we call it orthographic projection. And it's going to give you 6 views, but from each one of these views, each pair of them, one is redundant. So front and back are similar, left and right are similar, top and bottom are similar. So we just keep 3 of them. In the ANSI standard, we just keep front, top, and right, and we put them in this L-shaped arrangement. And then if the details are visible, we use solid lines. If they are hidden, we use dash lines. If there is a center or symmetry, we use dash dotted line, and so on and so forth, right? So this is what we need to send to a manufacturer, a lab technician, a machinist, anybody like that. And this is not enough, just the 3 views. Sometimes if the object is too simple, 2 or 1 views may be enough for them to visualize it and how it looks like, but for them to manufacture it, we need to basically convey a lot of information, including but not limited to the material of the part, the dimensions, location of the features, surface finish, tolerances, geometric tolerance, if there is welding included, and a ton of information. Okay, if there is heat treatment needed, and so on and so forth. So we have to put all of those info into a document that we send to the technician. So first thing is, if I have created a part in the part design, a component in the part design, how can I create these views out of it in SolidWorks, and then how can I add all those necessary information, okay? So we talked about orthographic multi-view projections. It's nothing new. We learned that we have some standard views, which we called top, front, and right. Out of the 6, we only used 3. And then we had some non-standard views that I briefly mentioned, but we're going to see how to do it in SolidWorks. And those include section view, detail view, auxiliary view, and we're going to see there are more in SolidWorks. And we also learn about the meaning of different lines. Specifically, the ones that we do and use a lot is visible thick line, then hidden line or dash, then we have the basically short line dash line, which is a symmetry line. So that's this guy here. And then we have the short long dash line with the thicks at the end, which is for cutting plane. Then we have the zigzags and the breaks, long break, short break. So we're going to see most of them in a CAD software, okay? Even thin solid lines for extensions, for dimension lines, for leaders, and so on. We know about the hidden features, the priority of them. So the first thing we want to do here is, well, first we want to start doing this in SolidWorks, and we choose a paper size, and then we start creating the views, okay? So first thing we need is a part. If you have already made a part, you can start working on that. Or if you want something that is already made so that you can just download it and start working on it, I recommend that you go to Canvas and then go to modules and scroll down, and then you're going to see this tab here called demo files. And the one I'm going to work on is the very top one. It's called Chamfer Machine Hole Thread SLDPRT. So go ahead and download this guy. And now if we launch SolidWorks and then we click on New, so far we have learned part and assembly. Now this time we're going to click on Drawing. Of course, here we have the advanced option to create a drawing template, right? But for now, I guess we are just good by clicking on Drawing and say OK. And then we get this window and we can choose different sizes from A0, A1, A2, A3, and A4. And each one, as you go from top to bottom, the paper size is going to be smaller. So this guy here, this table, which we're going to see is called the design table. I'm sorry, the frame and title block is what we call it. This is going to be bigger compared to the rest of the paper. So choose any of them that you want and proceed. Let's say I want an A2 paper. And then you can see the dimension of that paper here, and then I say OK. And right off the bat, I'm going to see this model view window on the left side. And here is what is asking me to look up and browse for the 3D part that you want to create drafting out of. So I click on the Browse button, and then I click on this SLDPRT file I told you to download and enter. And here you can see on the left side that these are different standard views, right? Front, top, bottom, left, right, and rear, and isometric. And the one that is highlighted is the one that you are going to put on the piece of paper first. So right now it is the front view here. So the first place that I click will be my front view. So let's say I click here. And this is going to be the appearance of the front view. Then if I move the mouse above, I'm going to get, of course, the top view. Then if I move my mouse to the right, I'm going to get right view. I can get left view. I can get bottom. And if I move further, I can get rear view. So I only need, as I said, front, top, and right. And in this course, although isometric is really not a standard view, and many times it's not really needed because the technicians typically are trained enough on technical drawing that if you just give them the 3 views, sometimes even 2 or 1, they can imagine how the part would look like. But in this course, I always ask you to not only show these 3 standard views, but also you move your mouse diagonal from the front view and also show isometric. This helps a lot for 3D visualization. So click there, and once you have established these 4 views and you're done, then click on OK. So that's the very first step, creating the 4 views that we always need in this course: front, top, right, and isometric. Okay? Okay, so now that we added these 4 views to our drawing paper, we want to start modifying them and adding the rest of the information. But let me show you the tabs that are available in the drawing environment and other stuff that are important. So first thing is, on the left side, you see there is a tree. So the drawing environment also has a tree. And in the tree, there is each sheet that you have for drawing. So your drawing environment is not necessarily just one sheet. So here you can see down below that there is sheet 1, that is the active sheet right now, and you have added these views. But you can add more sheets just like in an Excel document. Okay, so all you need to do here is to click on this icon, add sheet, and if you do, there we go. Now you have sheet number 2 added to the tree. And each sheet you can have any view, any information that you want. And I'll show you later that this might be quite necessary for assemblies and large parts with a lot of details. Okay, So here now we have several sheets. If you don't want a sheet, all you need is right click on it and delete that, okay? So let's say I don't want sheet 2 right now, I just want sheet 1. So you have that sheet, you can edit some information about it here, I'll show you in a minute, and then each view that you added, the front, top, right, and isometric, they have names for themselves, drawing view 1, view 2, and so on, okay? So there is a tree, and each item you can just right click on it and you can access a bunch of different options for that item. And we'll discuss some of these options here. Another thing that I want you to look at is if you see the front view symbol is different than the other views. So because the front view is the center view and the other views are depending on the front view. How can I check that? Well, if you look here on these views, there is a frame around each one of the views, right? When you hover your mouse, you can see that. So now if I left click on the front view boundaries and drag, you see, I can move the front view, but the right and top will move with that if I move it horizontally or vertically, because they depend on this guy. But if I want to drag and move the boundary of the top view, you see, when I move that, nothing moves. The front view or the right, nothing moves. And the same for the right view, I can move it horizontally without anything else moving. So the rest of them are like projected views, are not projected because everything is projected, but they're like secondary views, and front views like the main view. The other thing I want you to focus on is on this top section here, there are different tabs. And the main tab here is called View Layout. This is where you can add different views for your part or your assembly. And we're going to show you how to use them. And the other tab that is really important is annotation, and here is where you add all the necessary information, especially dimensions and tolerances and so on. If you want, you can add sketches to your existing views or extra information. You can add some sketches, but typically once you have the 3D part, all you need is to browse for it, and then SolidWorks will create these views for you. So these sketches are basically for adding something in addition to these views. I'll show you, like modifying this table. And then you of course have Evaluate tab. You can still do some measurements here if you want to, although I'll show you once you go to the annotation and use a smart dimension, it will create any dimension for you, which serves the purpose of measuring as well. So we do not want to do a ton of work on this sheet format, especially this command that is a right click available here too, edit sheet format. And the add-ins, of course, nothing related here or evaluate. So the main two tabs I'm gonna work with is View Layout and Annotation. Good. So now, as I said, first thing, we can move these views. Okay, we can move them. And the isometric, if you see the isometric, I can move anywhere that I want. So it's quite free. It's not like the top and right that are always depending on front. This guy can be moved arbitrarily. Now, what should we do? That now we have the views. Probably one of the first thing you observed is, where are the hidden lines? This front view has all the solid visible lines, but what about that hole here? That's a machine hole. And what about this threaded hole? I don't see anything here, okay? And that is correct. The first time typically you bring stuff into SolidWorks, the default is it only shows visible lines. But can I add the invisibles? Of course. So what you need is you click on this front view just one time on the boundaries, and then you get this drawing view window on the left side. And here under display style, that's where you can change the rendering. And I recommend absolutely never to use shaded in drafting, but you can just use hidden lines removed. You can say hidden lines with dash or wireframe, and the one you want to choose based on the drafting standard is hidden lines visible. And once you do that, then not only the hidden lines will be added to the front top right, it will also be added to isometric. In this example, there is no hidden line on the top view. Everything is visible. Now, let me warn you of something that we never do in a drafting. In a drafting, if you remember from the past, we never add any extra detail to the isometric view. So in isometric, you should never ever show hidden lines, symmetry lines, dimensions, or anything. Isometric is just for visualization. You should not put any information on it because it's ideally a redundant view. So what I want you to do, although I need these hidden views in these two views, but on this guy, I would click on the boundary and then turn it back to what? Only visible lines, okay? By the way, probably you noticed when I clicked here on the front view, it shows that, well, I have front, top, right, all the 6 standards, and isometric, of course, but it gives me 2 other views that we barely use, and we identified them for you in the past, dimetric and trimetric. If you remember, dimetric is similar to isometric, the angles are different, and there are 2 scaling factors. Trimetric, 3 different angles, 3 different scaling factors. Isometric is the angles are 30, 30, 90, and for the 3 axes, X, Y, Z, and the scaling is 1-to-1 on all 3 axes. So that's one thing that you probably have noticed. The other thing I wanted to tell you is the scale. So you can choose to either have the sheet scale, the default, which is 1-to-1, or you can change the custom scale. So sometimes maybe the part is too big for the sheet size that you chose. Maybe you want to make these guys a little smaller or bigger, right? So what you can do is, instead of use a scale sheet, you click here and say, what? I want to use a custom scale, and instead of 1-to-1, I want to use a 1-to-2, right? Now you're scaling down by 50%. So you can choose to scale all of them up or down if you want to. For now, since these views have relatively good size compared to the rest of the paper, I'm going to use 1-to-1, but you have the option of changing the scale for all of them. So now that I am in a good position and I have added the views, put them in the right place, added the invisibles, and the scale or the size is enough, you might wonder, okay, what's next? And I'll show you. By the way, let me very fast mention these 2 top commands that are useful. So if you remember, when I started this, when I started a new document in Drawing, it gave me this window on the left that I could browse for the part, and then I could add all of these 4 views. Another way to do it is, if you close that window and not do anything, let me do it here again. So I'm gonna do it again from scratch. So I click on New, go to Drawing, and then go with this. And this time, instead of using this model view, I just close this, not do anything. So if I click on this model view, this is the same command that was open. So I can click on Browse, I can choose my part, and then I can bring in what? 1 by 1, all of those views that I had. So this is the command that in the beginning comes and asks you to basically add any view that you want. Another way to do it is, if you want to only add the 3 standard views and not the isometric, so just front, top, and right, then you can click on this guy here, standard 3 views, and you browse for the part again, and this one immediately add all 3 of them without you needing to move the mouse. So there we go, I added these 3 views. And this is typically, as I said, what a technician needs. But in this course, again and again, I'm asking you, please add the isometric. So you might say, well, when I added these three standards, how can I add isometric? Should I remove them and start from scratch again with this model view? No. This model view, you can add one view or so many views. So if I only want to add an isometric, I click on this and then choose this part again. And all I add with this command is I click on the isometric and what? I add the isometric and I'm done, right? So here I showed you how to use these two important commands, three standard view and model view. Okay, and again, if I click on them, I can change the scale, I can change the visibility of hidden lines. That's, I said, for the major views, you add them. Okay, so let's save it for now. I call it Drawing Demo 1. And I'm going to now start adding the other necessary information. Okay, so now that we know how to show visible and invisible lines, what about center lines? SolidWorks default is not to add the center lines most of the times. So let me show you an example. So here I'm gonna add the three views for a part called Pendulum, which is posted on Canvas under Modules Demo Files. And these are the views of the pendulum. And let's also show the hidden lines. Clearly you can see that the top view is symmetric about the mid-plane here, but that symmetry line is not shown. So if you want to add that manually, we go under Annotation, click on the center line, then since that symmetry plane is vertical, we click on left and right edge, and there we go. We got the center line. If it was a horizontal symmetry plane, then we use the top and bottom edge of this view. Most of the time for full circles, you are going to see a center mark added by default, but if it's not added, let's say here, if we delete this, that's the view that you get from SolidWorks, then you can easily click on center mark, click on the arc, and there we go. You got your center mark. Okay, so we can add these symmetry lines, center lines ourselves manually. Okay, now what about this table, which we call title block or frame and title block? What is it and what information does it contain here on the bottom right corner of our drawing page? What is this? What information does it include, or should it include? So of course the name of the company, the name of the person who drew these views, the name for them, which should be brief yet clear, drawing numbers for each sheet. You should have a drawing number, typically revision numbers, because the first time that you draw something, it's not going to be the final thing that you send to manufacturer. You always have somebody as a supervisor, especially if it's your beginning of career as a drafter, and that person with more experience would check your work and find the mistakes or errors, ask you to revise it, and each time you revise you have a revision number, and finally there is the approval block that the supervisor would approve your final work to be sent to the manufacturer. Because if you send something that has a bunch of mistakes in it, the manufacturer is not going to take their time to fix those for you. They just simply send it back. And this back and forth means waste of time, and waste of time in industry means waste of money. And so your supervisor will not let you just send your first draft to the manufacturer. You have to keep revising it, and once it's approved, then it's set to go. the scale, of course, the drawing size, the sheet number, and the weight of the part. Why is this weight, or actually mass here, is important is, of course, when they want to create a part, they want to have an idea of how heavy the part is and whether they need any specialized equipment to lift and manipulate the part. And additional information like the material, general tolerance, heat treatment, finish, hardness, and so on and so forth, okay? So let me show you how you can access the fields in this table, which is called the title block, how we can modify them, how we can type anything in them, and then go back to your views. So here, as you see, the fields in this table by default are not active. You cannot double click or change anything, okay? But if you go to, let me delete this sheet. If you have this sheet 1, okay, and you right click on this guy, says sheet format 1. If you right click on it and choose edit sheet format, now this title block goes blue, and whenever it's blue, it's active. Now you can type, you can modify. So let's say here I want to put my name as the name of the person who drawn it. So here you can see, if I want, I click on this note tool here above in the annotation, and then I simply click here, and then I type in m.a for my first and last name, initials, and then I can change the font size if I want to, the color, anything that I want. Let's make it a little even smaller, like 8, right? And then you can simply click on this guy, you can move it, and you can do anything you want to this block, okay? So here I move it to wherever it's necessary. If the font is too big, I can make it even smaller to fit. So let's make it 6. So now it should fit inside this table here, this cell. Okay, and you can add anything else that you want. So again, you can click on this date here and type today's date. So it's 15 that I'm making this for you, and I put the date over there. And then you can add any other thing. So material, you can click here and say this is like aluminum 1060, right? And you can modify anything that you want. The weight here, you can click here and say this is like 2 kilograms, and so on and so forth. Okay, so whenever you're done and you put all the info, and as we go through this course, I'll show you how to add more info to this. So once you're done with this, then what you need to do is go back on this sheet format that you right click first, you right click again, and then say edit sheet. Once you do that, again, it goes inactive, but now all of the info you put in is over there, and you're back to the drawing views and adding the dimensions and everything else. Okay, so this is how to modify this table. One other way that is mentioned in the lecture, when you right click on the sheet format and say edit sheet format, instead of going there and using the note A to type in something, one other thing that you can do is you right click again on this sheet format 1 and then say title block fields. Once you do that, now appears for you these fields in the title block. And what you can do is you just simply click on them. Okay, and you can edit them as well if you want. Okay, let me show you. So now you have editable field, let's say approved here. So this is the area that you can add anything you want, text field. Okay, but I typically prefer to use directly the nodes. So you can double click on them and modify them, as I said, but that's not my preferred method of editing. Or you can delete them. If you don't want something, you can just right click. Okay, no, not like that, but as I said, if I double click here, you see I can resize them basically at the very least, and I can move them and I can manipulate the fields. Let's see if I can, yeah, here. So basically you choose the fields that you want to be able to modify, and let's say I want to modify that field and this field, and you okay that. And now if you now go to here, you can double click and type whatever you want, and the same here. Okay, so as I said, let's say we added the info that we needed, and now we are back to modifying the views. So one of the first things we want to add to the views are the dimensions. And when we want to add dimensions, we have to keep in mind that we cannot just add dimensions arbitrarily. There are rules that we have to follow. Like what? One of them is you always put the dimensions to the side of the view, not inside. Okay, so, and between the standard views. What do I mean by that? So let's start and I'll show you. So let's say I want to provide all the necessary dimensions for this part. So one of the first thing that you always want to provide for any component are the three major dimensions: height, width, and depth. Always make sure you include those three important things to give an overall estimate of the size of the part to the technician. Okay, so here we are under annotation. I click on the smart dimension tool, and I come here and then I click on the width of the part. So I click on this edge and bring it out, and this size is 566, right? Okay, so when I create this dimension, I'm not going to put it like this inside the view. I always put it outside the view. And let's say if I want to add height, so I click on this, I put it what? In between the standard view, so between the front and the right. Okay, so do not put ever anything inside any view. It should always be outside. That's rule number one. Then the other important thing is never a dimension should be shown twice. Avoid redundancies at all costs. Okay, so here let's say this width is 566 and I'm showing it on the front view, so I'm not going to come again here on the top view and show this width again one more time here. Okay, this is redundancy. We should never do redundancy. Each dimension should only be shown once and that's it. Okay, so this is the dimension that I should, instead of hide, I would rather just click on it one time and then use the delete from the keyboard. Okay, so avoid redundancies at all costs. Now, when we show linear dimensions, and linear we mean the size of the straight edges. So when we show, or the distances between points or other features, So for linear dimensions, there are two ways to show, especially the locations or the sizes. One is called stacked method, the other one is called chain method. So in the stacked method, when we want to refer to the size or location of features, we refer all of them on one side to the same feature, to the same entity. So here you can see that the distance between this vertical wall, and this vertical wall, the distance between all of them is shown to what? To the left edge. So one side of all of these measurements or distances is the same. We call this stacked method. In chain method, that's different. Instead of, let's say here, this first vertical wall, I show it with respect to the left edge, but then the second vertical wall is not shown, the distance of it is not shown with respect to the left edge, it's shown with respect to what? The previous vertical wall. And so when I come to the very last vertical edge on the right, I expect that distance to be shown with respect to the second vertical wall or vertical edge, but here you see the rule is not exactly observed. So the last part of this chain, so each dimension is like a part of a chain. The last part of the chain, instead of showing the last part of the chain, I'm showing the total length of the chain, 3 here. Why do I do that? That's a rule that we should always observe. They always say in chain dimensioning, you always leave the last part of the chain and show what? The entire length of the chain. Why? I'll show you later when we go to tolerances. Okay, but that's one of the major rules. The other important thing is, so we learn about chain method, okay? We never show the last part of the chain, we show the whole dimension. And let me show you maybe over here. So, for example, let's see what I can show you. Although this is not really the best way to do it, but if I want to do it over here, so here the distance between this point to the bottom edge is shown, and then instead of me coming here and showing the distance between this point and this point vertically like this, right? So here this 2.05 and 1.18, these are the two parts of the chain. I'm not going to do it that way. Instead, I would show the distance between the top edge and the bottom edge, which is the total length of the chain, right? And then I would delete this 118. So first of all, I'm not going to show all three of them together because one of them is redundant, clearly. So I click on the last part of the chain and what? I delete that. So this is how I show it. This is the correct chain method if I want to use it, which is, in this case, because I only have two of them, it's also similar to the stack method. So that's one thing. One other thing that we have to keep in mind, we try to avoid intersection of the dimension lines together. So here, this guy is the dimension line, and these thin solid lines are the extension lines. So one thing we always want to try is that the dimension lines, the arrows, double arrows, are never crossing each other. Can they cross each other? Can they intersect each other? Yes, I'll show you that, especially when you have a combination of linear and circular dimensions, it's really easy to get them crossed like this. For example, here, if I click on this edge and provide width, and then if I click on this diameter and provide diameter and do something like this, you see now this leader, which is a dimension line, is crossing the other dimension line at this point. Okay, and this is one of the things that you always want to avoid in any drafting. No two dimension lines should cross each other. That is an absolute must. So what should I do? I should move this radial dimension elsewhere so that they don't intersect. Now, what about the extension lines? So here, if I bring this smaller dimension outside of the bigger dimension like this, what about this? Here the dimension lines are not crossing, but the extension line and the dimension line are crossing. Is that a mistake? Well, although it's not an actual thing that is considered as a mistake, but it's not preferred. So you should really try to avoid intersection of dimension and extension as well if you can. And to do so, you always place smaller dimensions closer to the objects and longer distances, longer dimensions further away. If you do so, then the intersection would also be avoided. Okay? So try not to cross, put everything inside, no redundancy. We talked about all of those. Now for radial dimensions, we said no intersection, place also those dimensions outside. So here, if I come back here, by the way, this guy is a redundancy, but we learned not to intersect, but in order to avoid intersect, I'm not going to put that radial dimension, that diameter inside. So I'm not going to do this. Okay, so radial dimensions, which are the dimensions for arcs, should also be put outside, but where that no intersection with linear dimensions is possible. So first of all, here in this case, this 566 is a redundancy, so I would get rid of that, and I put this diameter outside. Okay, so what else do we need to know? If we have an entire hole, a full arc, a full circle, then we should always show it with diameter. If it's just an arc, then we always show it with radius. That's a very, very important rule, and that's the source of mistakes for so many of my students in the past. So again, whenever it's full circle, you always show its diameter. Whenever it's not full circle, you always show radius and not vice versa. Okay, so here, because this machine hole here is full arc, full circle, when you click on this guy, you always show what? Letter phi, and phi means what? Diameter. You never show radius for that. But if there is any, let's say fillet or something, or a half circle, then you always show the radius. And this smart dimension is smart enough that it knows the difference between them, so it will choose for you phi and r. Okay? So one last thing that you need to know is when you have a full arc and you want to show diameter, where would you show that? In which view? So here, if you look at this part, I have this cylinder, I have this extrude, the outer circle, which here looks like circle in the top view and in the front looks as a rectangle. And then I have the inner circle, which is the cut extrude, and again here showed with a rectangle but with dash lines. So if you look here, the diameter of the extrude is shown in the front view, but the diameter of the cut extrude hole is shown what? On the top view. And you might wonder, well, couldn't we show both of these diameters on the front view or both of them on the top view? And the answer is no. There is a difference. What is the difference? The difference is this. When it is a solid object, an extruded object, a swept object, loft object, it's a solid part. You always show diameter where? You always show diameter in the view that the solid parts appear as what? The solid cylinder appears as what? As a rectangle. You never show it on the view that it appears as a circle. So I repeat that. Whenever you have a cylinder, okay? Whenever you have a cylinder, you always show the diameter of that in the view that it appears as a rectangle. Exactly opposite to that is when you have a hole. Whenever you have a cylindrical hole, you show the diameter on the view that it appears as what? As a circle. Okay, so that's the rule. Plus, there is another thing that's, in this case, it would help you is if you want to put the diameter of the hole on the front view, then you have to show it between what? Between the dash lines. And that's another important rule in adding dimensions to drafting is you try to avoid adding dimensions on what? On hidden lines as much as you can. So really try to show dimensions always between what? Between solid edges, never between hidden edges. Okay, that's another rule that you have to observe. Okay, so these are the important rules of dimensioning that you have to pay attention to. Now, if I go back here, right? So as I mentioned, you have the first thing you have to show is you have to show the three major dimensions: width, height, and depth. So here on this view, I have shown width and height, and then I can show the depth on either top view or what? Or on the right view. So let's say I choose the top view and I click on this edge, and there we go. I provide the depth. Okay. Now you might say, well, these dimensions are too small. When I print them, it's not going to show themselves. And you probably are right. So unless I zoom in, I cannot see them when I look at everything fit. They are too small. Even if they are printed, they are not going to show themselves well. Can I make this font size bigger? And the answer is yes. If you click on that dimension and this dimension window appears on the left side, then you click on Other. Then uncheck this guy says use document font, go on the font and change the number of points from current number, which is 13, to a much bigger number, let's say 48. Okay, and that will change the font size for that dimension. So what about if you have several dimensions? Just select all of them together. Okay, so you can select all of these dimensions together just by a simple basically highlight method like this. So select everything that you have, click on Other, change the font size, and you should be good to go. So you can multi-select and change all of these dimension fonts together. Okay, so we learned how to change the font size for several dimensions at the same time by multi-selecting. The caveat is, let's say I change these three dimensions font size, but now I want to create a new one. So if I click on this hole to show the diameter, you see again, because the default font size is smaller, so this new one that you generated will be smaller than the rest of them. And the same if you want to add more and more. So it's not a good idea that really you once in a while select the dimensions that you have created, multi-select them and change their font size. It's a good idea if you can change the default font size so that whatever you do from this point on will be with the larger font size. And to do so, what you do is you go under Tools Options, and then you go under Document Properties, and then click on Dimensions. And then here under Text Font, you click and then you change the number of points or units for the font size. So I change it to 48. And now, if I click on anything else from this point on, you see that the dimensions, the font size will be bigger, okay? So do it in the beginning. That's one thing. The other thing I wanted to mention is sometimes you need more than 2 decimals. The default is 2 decimals, but what if you need 3 or 4 decimals? So again, you can click on any of these dimensions and then come here on this window on the left. And you have tolerance, which we'll talk about later, but the second window here is the precision. And for precision, you can change it from 2 decimals to any number that you want. Let's say 3 decimals for now. And there we go. But what about the others? What if you want to change all of them to 3 decimals? Again, you can multi-select and change, but the better way to do it is, again, through Tools Options, Document Properties, Dimensions, and change the primary precision here. Okay, in this way, all of them would go 3 digits, as well as anything else from this point on will go 3 digits, 3 decimals, I'm sorry. So that's the way to change the font size, okay? Now, let's go back to the lecture. So I showed you how to change precision and font size from options. Again, I mentioned that in the past, but I emphasize it that some parts might be too simple and 1 or 2 views could be enough to tell anybody the details of the component. But in this course, for any assignment, homework, quiz, project, anything, I always ask you to show all of the 4 views, front, top, right, and isometric, even though they might be redundant, okay? So please always use the 4 views required in this course. The other thing is, if you ever want to print something, probably for this course, if you want to be fully online for the rest of the semester, we are not going to print anything, but for yourself, if you ever want to print any of your work here, when you open up SolidWorks in the beginning, the default background color of the drawing document is quite a light yellowish color, which if you print it, it's gonna waste a ton of cartridge. So let me show you. If you go under Tools Options, and then under System Options, you click on Colors, and here under this Color Scheme Settings, you scroll down to Drawing Paper Color. So the default color is something like this. Okay, probably that's what's, when you open it first time, that's what you see. And I absolutely do not recommend printing this. Okay, although SolidWorks might have the option to print it with white color. Probably it can do it. It's quite maybe smart enough. I can try it right now. I have a printer handy, so I can try it, but I don't want to take any chances. Plus, I hate this color, to be honest with you. So I changed the background color of the drawing to white here. And so whether the system works smart or not, I'm sure that the background is white, so when I print it, I'm not going to waste my toner. Okay. One other thing, I told you that when you right-click on many things in the drafting or drawing environment, it's going to give you the contextual menu and more options. The same happens for dimensions, okay? And this more dimensions option typically give you some stuff. Like, for example, here, I created the diameter for this hole, and diameter, I told you, it's always letter phi. So whenever you see phi, that means diameter. And although we absolutely never show, excuse me, the full hole or full circle with radius, I told you that's not what you should do. But let's say if I just wanted, for this case, just show you how to use this option. If I want to show the radius of this hole instead of diameter, is there any way that I can overwrite SolidWorks default? The answer is yes. If I right click on this dimension, and here it says more dimensions, okay, that's one of the things that can give you options. But better than that, if you go under display options, so more options is typically for linear dimensions, making it horizontal or vertical. But the other option you have here is display options, and here you can say, hey, display it as a radius for me, and there we go. Okay, but again, I absolutely do not recommend you do such thing unless it is a fillet or a partial arc. If it's full circle, you always show diameter, okay? So just wanted to show you this display more and the more dimensions. Okay, now let's talk about a bunch of other things. So one is multiple features. So whenever you have something that is repeated, you have several instances of that, you're not going to show the dimension for it several times. So here, let's say I have what? I have 16 holes, and the diameter for each one is 1.181. I'm not going to show 16 of these dimension leaders and the numbers all over this view, okay? It's going to be super crowded, busy, and it doesn't look any good. So instead, I use an n times, okay? And n is the number of the instances. So here I say 6 or 18 times that dimension. The other way is after the dimension number, I can use TYP, which stands for typical. So I can say, hey, this guy is a typical thing, okay? So I can use both of them to say that this feature is repeated. And let me show you something for that. So let's see if we have anything like that on Canvas. By the way, as I mentioned to you, now the video lectures are not posted under modules, okay? So if you go under modules, you don't have that video lectures here, but if you go under pages here on the left, if you click on pages, and here you click on the video lectures, these are the lectures prior to this session that I have recorded and uploaded for you here. So anything that I will record from this point on will be posted under pages, not under modules, and that's due to space limitations I had for storing stuff under files. But for pages, I can directly bring them from Studio where I record these videos, okay? I can link it to the studios instead of uploading it directly. So it's not gonna waste my Canvas space. Okay, so if we go under modules, let's see if I can have something for you that you can work for multiple features. So if you go under demo files, that's this guy here. It's called multiple features SLDPRT. Go ahead and download this guy. And now I'm gonna click on sheet 2 and then click on the 3 standard views and then browse for this new part. And there we go. Okay, so here this top view has 16 of the same thing. So when I want to provide diameter for these holes, I click on Smart Dimension and I click on this one, and there we go. Okay, I show the diameter. And maybe it's a little too big, so let me bring down the font size for this. So I'm gonna use maybe 28. Okay, so now I'm not gonna, as I said, show 16 more, 15 more of that on 16 places. Okay, so I'm not gonna do this and then this. Okay, this is not what you want to do. Okay, you're not gonna do that and then put 16 of them. Instead, what you do is this: you right click or click on this dimension. If you just click, you don't need right click, and come down here to where it says dimension text. Okay, so if you see what is going to be shown is first mod diam. So this is the symbol of that dimension, which in our case is phi. Okay, and then what? The dimension itself, the value itself, right? So since I have 16 of them, if I just before that mod dia, I say 16 times and use X for times, there we go. Okay, it's over, done. And I say, hey, there are 16 of them. So that's one way to do it. By the way, the 16 times should always be before the dimension value, not after, okay? I had students in the past who did it like this. This is wrong, okay? Either this, or worse, I had this, like this. Don't do that. Bring that 16 times before the value. If you want to bring anything after value, that's the keyword TYP. You can do that as well, okay? Typical is also another way to show it, but I always prefer n times over typical because it exactly tells me how many of them I have in the drafting, instead of just saying, hey, it's a typical, you guess how many of them I have. So I recommend use n times for multiple features. Okay, now if we have several holes in an object, if there is anything repeated, of course, we can use that, but we can use chain method, we can use stag method for showing the linear or radial position of the holes. For machine holes, not only we have to provide the diameter of the hole, we also have to provide depth of the hole. Now, when we want to provide the depth, if we go back to this sheet 1, this example that we had, so here, this guy here, this one is a machine hole, and I'm showing the diameter of that on the top view. But where can I show the depth of this hole? Well, you might say I can show it here on the front view or on the right view, and yes, you are right, I can. So I can here come to this, let's say, right view, click on this edge, bring it out, and say, well, that's the depth, 1.575. That's correct, or I can do it here. But as I said, one of the rules of drafting says try to avoid putting the dimensions on invisible lines as much as you can. And right now I'm showing it on invisible, on dashed lines. So instead of doing it this way, what I would do is I show that oh, come on. 1 second. Doesn't want to go. So you can show that dimension, that depth over here. How? Again, you can add it to the dimension text. So you see here, I could add n times or something. I can also say this is 0.394 diameter and then what? 1.575 what? Depth. And for depth, the symbol is this guy here. Downward arrow with the horizontal line. So I add that as well, and there we go. So this is a better way. I show everything on that top view, and I show diameter and depth all in one single view. So I recommend this over using depth in another view or on the dash lines. Then we have threads. So if a hole is machined and threaded, then you want to use the standards for showing threads. If you remember, I told you that we have two types of threads. We have metric threads and we have SAE threads, or British system. And metric threads, they all start with letter M, and M, after M comes the diameter, the basically max diameter of the thread, and then comes the pitch. So when we say M12 cross 1.5 or times 1.5 means the major diameter of the thread is 12 millimeter and the pitch is 1.5 millimeter. Okay, so that's how you show a excuse me. Now don't worry, it's not corona, it's just probably a little cold, but that's how you show a metric thread. For SAE threads, instead of pitch, so we still show the major diameter, but instead of pitch, if you remember in class I mentioned, we show the number of threads per 1 inch. Okay, so just keep that in mind. So if I go back here, this other hole here, this one is a threaded hole. So if I click on Smart Dimension and I click on this guy, you immediately see, because it's a Smart Dimension, SolidWorks knows it's threaded, and it says what? It's M12 times 1.5. Okay, so SolidWorks will do the dimension properly for me. By the way, let me show you something, a difference between a simple hole and a threaded hole. How would you recognize that one hole is just simply drilled and the other one not only drilled, it's also what? Tapered and it's threaded. So if you look at these two holes, by the way, this symbol, I don't know why SolidWorks is adding that, but this guy is not the centroid of this object, it's just a simple hole. So other than this crazy thing, there are several ways to tell whether the hole is threaded or not. One is the simple drilled hole without any thread is just a simple circle, but the threaded hole has two circles if you look from the top. But better than that, when you look from the side, that's where you can tell. So this guy here is a simple hole, but this one is a simple hole, and this outer rectangle is what? The thread. Okay? So not only you can see that basically this is the depth of the drilled hole, also this is the depth of what? The thread. So in our case, when we show this M1211.5, we also have to show what? The depth of the thread, which is this size from here to here. So that's this guy, 0.945. So you have to show it somewhere to tell the machinist how far to go for creating threads. And also you have to provide the depth of the hole as well. So you have to show them, and again, you can use those numbers over here. If you want, I can add that 0.945 over here, right? So I can simply click on this guy and then provide the 0.945 and then depth of the thread. Okay, so this is how to distinguish between simple hole and hole with threads. If you have inclined surfaces, for inclined surfaces you need two dimensions. Either you provide the horizontal and vertical offsets, which we call them rise and run, or you use just one of the rise or run and the angle. So one of the things that you never do for showing the dimensions of an inclined surface is to show the length of the diagonal. You never show the length of the inclined surface. You always show rise and run. Okay, so if we go back to SolidWorks here, let me show you that. So if I click on the smart dimension and I click on this guy, I'm not gonna show this diagonal length 1.670. That's wrong. I either show rise or run, and the question is, well, how do I do it? Well, all you need is, if you just move your mouse here a little vertical to the left, now the dimension will go vertical, and if you move it a little down to the right, then it goes what? Horizontal, right? So I can show it with this, and then what? With this one. Right? So that's the rise and run method. Or if you don't want rise and run method, you can get rid of this and you can show the angle. To show the angle between two lines, you have to select them both. So you click on the first line, then you click on the second line. And you can move it around in all four quadrants, okay? And you can show what? The angle that you wanted, right? So you can see that I can bring it out like this, and I show the angle plus the rise or run here actually. And you might say, what about these two extension lines that are intersecting? Is that a problem? The answer is no, it's not a problem. As I said, the problem is when the arrows are crossing each other. That's a definite mistake. If an extension line crosses a dimension line, that's not preferred, but that's not a mistake. But if extension lines are crossing each other, that should not be a problem at all. Although you can move this guy to this side too, okay? You can move it to this other side and avoid that as well if you want, but it's not necessary. So I can, as I said, click here, and bring this guy like this side. But if two extension lines cross, there is no problem. Then we go to chamfer. Now for chamfer, it is an inclined surface, but it's a small one, which the only purpose is to remove a sharp corner. So it's quite different than an inclined surface. So when you want to show a chamfer, instead of showing the rise and run, or the rise or run and angle as two separate dimensions, you combine both of them into one dimension and use one single leader and separate those two measurements with a cross. So you say it's a 2x2 or 2x45 chamfer. So that's how you distinguish between chamfer and what? Inclined surfaces. So let's say in this case, it's a chamfer. It's not an inclined surface, although that's quite big, but let's say that's a chamfer. So instead of showing these two dimensions separately like that, what I do is I expand this smart dimension, and instead of clicking on it, I come down and choose this guy, chamfer dimension. And when I click on this edge, okay, then it is waiting for you to use another edge as reference. So I use this edge as reference, and there we go. Yes? So now you can see that the information is provided. So that's how you do chamfer. What if you have an SP line and you want to show the points through which the SP line is passing, like an airfoil? So there are so many points on the airfoil, and if you want to recreate that SP line, then you definitely need the location of those points, X, Y of those points. Well, you cannot provide with offset the distance between point 2 to point 1 horizontal vertical, between 3 and 1 horizontal vertical, the same for 4, 5, and so on. So in this case, if you want to do it, you're going to see 12 minus 1 times 2, 22 dimension lines and extension and everything all over the place to just show the offset of these points with respect to point 1. You don't want to do that and make this super crowded. Instead, you simply put a number next to each point and then provide the coordinate of those points with respect to the same origin using a table. So you use the table and use the notes for providing the numbers next to the points. Okay, that's an efficient way to do that. So let me show you that one. So if I go here under this sheet 3 maybe, and let's see if I can create that here using the sketch instead of me creating a part with SP-line. So just for the sake of demo, I click on SP-line and then I create an SP-line passing through, let's say these many points, 6 points here. Okay, so this SP-line is passing through 6 points, and now I want to show to you the coordinates of these points, all, let's say, with respect to the first point. So I put the origin at the first point. So what do? So you go to annotation, you click on note, and then you click on the points, you click on the note, and there we go. You provide numbers. So that's point 1, and let's see if I can just put a number here. So I recommend you just not click on the point, because then it shows you a leader and that's gonna create some extra space. So if I go to this one, let's make it a little bigger font, maybe this, right? And then can I copy this? Yes. So then you find point 2, which is here, right, and so on and so forth, and then keep going. So let's say 3, 4, 5, and maybe 6 here. So where are these points? So this point is here, we change that to 3. The next point is here, so we make that 4. This point is here, make that 5, and then finally this point is here, we make it 6. Okay, so these are the points. And by the way, if the points are not showing themselves, so here you see I'm showing the SP line, but whenever I click outside the SP line, the major points are vanishing, right? It's not going to show them. So if it gives you the option here to make them visible, let's see, under options, it does not allow me to see the points, okay, and keep them always there. So if it doesn't happen, then you can use the, let's see if the point itself can be, if I fix that, does it do anything? No. So if you want, you can use the, under sketch, you can use the point tool, right? And you can come here and then put a point here and then put some point here and move it around and so on and so forth, right? So you can add artificially some points over there, right? Okay, so you say this point and then this point, you can make them coincident. And you can fix the SP line. So let's say I have created the SP line, I have created the points and everything. So now under annotation, I go and create a table. And that is your table here. So say I want a general table. And then it says, okay, how many rows, how many columns? So here I have 6, so I need 7 columns and I need 3 rows. And I put it here, and then here I double click on each cell and provide the info. So I can click here and say this is X, double click here, make it Y, then make it 0.1, 0.2, 0.3, 4, 5, 6, and I can move this guy around. I can probably resize it like this. And then let's say I want to know the coordinate of 0.2, so I just click here and here, and I get that X is 6.34 and Y is 6182. Okay, so 34 and 182. Something like this, and then you fill the table, and this is an efficient way to show the coordinate of these points instead of showing a ton of dimension lines between the first point and everything else. Finally, if you have an assembly and you bring in the assembly, one of the things that you need to do in assembly is using balloons, and balloons are used to give the part's name or part's number to each part in the assembly, and basically it's for general instruction or general knowledge to know that which component is what in the assembly, right? So let's say you bring this assembly in and then say, well, this is the piston, this is the pin of the piston, this is the connecting rod, and this is the crank bearing, and then passing through this is the crankshaft, and so on and so forth, right? So whenever you want to distinguish between the components of an assembly, you always use balloons, and this is an extremely useful tool. So let me show you very fast one thing about assembly. So if I go here, and then I have downloaded from Canvas this assembly here. So if you go down again under demo files, there is this assembly 1 SLDASM, which is a pendulum. So you need to download this as well as support SLDPRT, pin SLDPRT, and pendulum SLDPRT. You need all of these 4 files. And then what you can do is you create 3 standard views of assembly number 1, okay, like this. So if I want, I can show you also the isometric of this. Okay, so this is something I made, simple demonstration. And now let's say I have three components, right? The pendulum, pin, and support, and I want to show them on this isometric view. So what I do is I go under annotation, and then I click on balloon, and then I click on, let's say, this first component here, bring it out, and then now I want to change the name from parts number 1 to support. So I double click on this guy. Okay. Cannot be changed because it's driven by order. That's correct. So by default, it's set to go by numbers. But if you come down here under setting, first you can change the shape of the balloon from circular to anything else. Circular is the common one. The other thing is, instead of here, it says balloon text. Instead of item number, you change it to what? To text, okay? And instead of 1, now you say what? The name of this guy is support, and you okay that, now it shows. The problem is the size of that circle is not changing to accommodate the bigger text, but you can change it, so automatically doesn't change, but you can change that. If you click back on this here, the space that is provided is for 2 characters, but if you change it to what? Tight fit, now it can include the whole thing. Okay, so you add that, and then you can go over the other ones and say, hey, now by the way, this guy is called pendulum, and again tight fit, and finally this guy here, it is called the pin. Okay, so this is how you do balloons. Pin, tight fit, thank you. So this one seems like it hasn't changed. I think I didn't click on OK for some reason. Pendulum and tight fit. Good. So this is how you use balloons. Now, where would you use balloons? Do you put them on the front view, top right, or isometric? My suggestion is you always show it on isometric because you can see more of the assembly. In each one of these views, you cannot see as much detail as you can see in isometric. So please put the balloons on isometric. Now, sometimes in the homework quiz or exam, I might say, well, show the isometric of the exploded assembly, not the assembled version. So show the exploded assembly and show the balloons on the exploded assembly. Create an isometric of the exploded assembly here in this environment. And you might say, well, when I clicked on isometric, it gave me the assembled version, not the exploded version. So how can I make it happen? Well, in order to do so, you have to first go back and open up that assembly in the assembly environment. So here, you open it like this, and you apply the exploded view first and save it, okay? So here, if you remember, I click on exploded view, and then I apply an exploded view here. So let's go with the steps. So I move this like this, and then I click on this guy and bring this back like that, and I OK it and I save it. Then if I go back here, right, first let's see if we just do rebuild, what happens. Well, apparently not that smart to change this, but if I go back, let's see if I now say, well, bring me an isometric of that assembly, which is now exploded, and click on this. Yes, now it is bringing in the exploded assembly, and of course now I can use again the balloons and provide the info. Okay, so again, if you want the exploded assembly, first explode the assembly and save it, then come and create the isometric view. Okay, so I guess at this point I have covered the basics for the drafting. Let me summarize the important rules for creating dimensions. The important ones are: first, you always put any dimension outside the views. Never provide one dimension more than once. Never provide redundant dimensions. If there is chain method, always leave off the last part of the chain and show the overall length. And let me remind you of what I meant by that. So if you remember, I told you we have two methods for linear dimensioning: stacked method and chain method. And here, in the stack method, everything is referred to one reference. In chain method, everything is referred to the previous entity. Now, in the chain method, instead of providing the size of each portion of the chain, all of them, we show them all except for the last one. And instead of the last one, we show what? The overall size of the chain. Why do we do that? I'll tell you why when we go to tolerances and I mention what's the reason behind this, okay? But you always observe that. Then if you do a stacked method, always place the larger dimensions further away and smaller dimensions closer to the view so that the extension lines and the dimension lines do not cross each other. And by all means, always avoid crossing dimension lines. Then apply the dimensions to visible lines only unless there is no other choice, although I'll show you in the next lecture we can always apply a section view and do put the dimensions on visibles. We can make invisibles visible by applying a section view, but try to avoid that. Then dimension lines should never cross each other. Extension lines may cross. Extension and dimensions are preferred not to cross. For radial dimensions, if it's the full circle, always show diameter. If it's a fillet or an arc, always show radius. Then the diameter of the cylinders is shown in the view where they are rectangle. The diameter of the holes are shown where they are circle. Okay? So let me add that. Seems like I'm missing that rule over here, although I mentioned it, but let me add that for you here so that you do not forget the thing. So 8 is going to be for a cylinder, show the diameter on the view where it appears as a rectangle, but for a cylindrical hole, show the diameter in the view where it appears as a circle.